Section 3.6, the variation of enthalpy with pressure at constant temperature. So in this case, we hold temperature constant and see how enthalpy depends on pressure. For ideal gas, that dependence is zero, because for ideal gas, enthalpy only depends on temperature. However, for real gases, liquids, and solids, enthalpy does depend on pressure. And enthalpy can be expressed as a function of temperature and pressure. Therefore, dH is delta H over delta T times dt plus delta H over delta P times dP. Again, if a system undergoes a change from the initial state to the final state, if both temperature and pressure change, we can design a two-step process, and then we can calculate the enthalpy change in step 1, a isobaric process, and then the enthalpy change of step 2, that's isothermal. We sum up the enthalpy change in step 1 and step 2, we get the total enthalpy change. And this term is simply C sub P, the isobaric heat capacity. This part can be proven to be volume minus T times delta V over delta T under constant pressure condition. We can prove this after chapter 6. For an ideal gas, delta H over delta P is simply 0. We can prove that. For a real gas, well, delta H over delta P is roughly 0. For a solid and liquid, delta H over delta P is equal to V minus T times delta V over delta T. And remember, beta is 1 over V times this derivative. Therefore, delta H over delta P is V times 1 minus T beta. This is roughly volume, because beta is usually very small. Beta for liquids is usually 10 to the power of negative 3 per Kelvin. For solid, it's usually 10 to the power of negative 5 per Kelvin. So at the room temperature, T times beta is roughly 0.2, 0.3. For liquids, T times beta is 0.002 or 3 for solids. Therefore, T beta is smaller than 1 for liquids. T beta is much smaller than 1 for solids. Therefore, sometimes for convenience, we'll just say delta H over delta P is the volume of the liquid or solid. And then dH is Cp dt plus VdP. Delta H is the integral of Cp dt plus the integral of VdP. Cp is roughly a constant. It does not depend on temperature significantly. So if the temperature range is moderate, we can simply just say Cp is a constant. This part is Cp delta T. And this part is even easier. The volume of liquid or solid is roughly a constant. So the integral of VdP is roughly V delta P. In summary, enthalpy depends mostly on temperature. For ideal gases, enthalpy depends only on temperature. Enthalpy does not depend on pressure at all. For real gases, enthalpy does depend on pressure, but the dependence is very small. For liquids and solids, delta H over delta P is also very small. So we can say for all substances, enthalpy depends mostly on temperature.